Uh, in this session, mainly I wanted it to be a kind of a discussion and probably opening opportunities for collaboration. So Paul will speak mainly on the Transforming Food Production Program, and there are, I think, 2 or 3 new calls coming. One is on the October 25th and one on November. And I will just give you some examples of some of the work which we are doing at Essex. On agri-food robotics and what are the challenges and where we are. And then we can open the room for discussions or yeah, if you have any suggestions, please feel free to jump in anytime. So with this, should I go to Paul?
Yeah, that's good.
Is this the other side? Paul, do you need this?
I'll try to. Either way, it's fine. Yeah, good morning. Morning, still morning though. Good morning, everyone. My name is Paul Laniran. I'm one of the innovation leads at Transforming Food Production Program at Innovate UK. And I'll be talking about, I try to be very creative with my title though, but I'll be talking about responding to existential food crisis. Now, I felt very, very not too smart after I listened to Rob this morning because, I don't think anyone can beat that presentation this morning. But I'll try to do my best, and where I can't do my best, I'll just skip. So as part of introductions, I'll talk about the existential issues we have that are affecting food production. I'll talk about the strengths that the UK has, either as a country, both academia and the industry. I'll talk about how Innovate UK has been responding and what we're doing in the future to respond to those. I'll talk about the Farming Innovation Program, which is something that everybody wants to listen to. And then I'll talk about, just give brief examples of the recently closed funding opportunities that we've had, and just give some examples, and then I'll talk about the support that is available for everyone. So I'm not going to try to recreate what Rob has done. He's done a fantastic job in trying to talk about the 3 Fs, labor, and all the challenges that are facing food production. And one of the things that was quite interesting was when he talked about consumer demands and consumer trends, and how consumer demands drive food production. Nowadays, everybody wants to eat better food. Well, maybe better food, but at least with less pollutants in the atmosphere and in the environment. And there's also that great need to reduce food waste. He talked about the black soldier fly, some of the projects that we funded, and I cannot but just gloat about this for a minute, if you permit me. When he talked about the net zero egg, we've got something called the net zero fertilizer that we're also currently funding at the moment, which is quite interesting. But yeah, there's all these issues are real-time issues that are confronting us today. And supermarkets supermarkets are driving farmers to holding them more accountable to producing more food at a cheaper rate. But also farmers at the other end want to make profits. So how do we merge these two issues together? It's important to understand that the UK food and agricultural sector is quite diverse. If you look at it from the livestock industry to the horticulture industry to the crops, and there are a lot of strengths that we've been able to amass over time, which is either with the academia, with the research communities, innovative companies and businesses that are driving those solutions that the farmers or producers, primary producers need. And also, the crossover from other technologies. If you look below here, the image you see, it's one of Innovate UK funded projects, which is trying to reduce the, trying to reduce the amount of pesticides that we use in strawberry production. And basically what they do is they use UV light to treat the crops in the field. And this is a very good project. It's based here in Kent at Clockhouse Farm, and they've done quite extremely well. I'm not going to talk about Vishu's project because I know he's going to have time to talk about it, but that's another fantastic project that I think we should watch out for in the future. So how has Innovate UK been responding to all these challenges? We initially started with the 70 million agri-tech funding for research and development, and we moved to another 120 million pound grant for the 4 agri-tech centers. I know if you've heard of CHAPS, CLs, Agri Epicenter, and Agrimetrics. And then we're about closing the 70 million pounds ISCF Transforming Food Production Challenge, which has funded a lot of innovative projects over time. And then we had a brief pilot of what we call the Farming Innovation Pathways, which was what we further developed to this 270 million DIFRA Farming Innovation Program. The pathway was just, was built on the success of TFP, and the DIFRA Farming Innovation Program has been built on, the lessons we learned during the pathways. So what is exactly this Farming Innovation Program? It's a part of the DIFRA's agricultural transition agenda, and it's supposed to, 270 million has been earmarked to fund research and development up to 2029. And the aim is basically to enhance productivity, to improve the resilience, to enhance sustainability and drive the sector towards net zero. Those are the big major 4 aims that Farming Innovation Program has. And they are collaborative projects, but because it's DIFRA and the fact that the agricultural budget is devolved, all projects must show benefits to England's farming systems. And one of the interesting things is that, I'll talk about it, just on this slide, is that we encourage a lot of collaboration, across the supply chain. Now, under the Farming Innovation Program, we have 2 big themed, 2 major type of competitions. We have one which is called the industry-led partnerships, and this is where the industry comes together to set the agenda of what they want and what solutions they think they need on the long period of time. And then we have the themed competitions, which we call Farming Futures Fund, which is usually in response to that government agenda or other things. And we've launched quite a few of the themed competitions. We've launched climate smart farming, sustainable farm-based proteins, robotics and automation, and environmental resilience so far. We are looking at launching a few more in the next couple of months. I don't know when specifically, but plans are on the way in those areas. Under the industry-led partnerships, we have the research starters. And that is one of the most innovative competitions that I've been working with so far. There are very small amounts of grants that allows farmers to trial out or respond to issues that they or their farming community has. So basically, we're trying to build a citizen science type of farmers, where farmers are actually looking at the problem that they are experiencing, even before it comes to research, and they're saying, we have this problem. How do we solve this problem? What do we do with this challenge that we're having? And then we have the feasibility studies, which is a slightly bigger type of grant. Then we have the small and large R&D funding. Now, please don't assume that small R&D is small in any way. It's just small because we couldn't find a better name, really. And like I said, we encourage businesses within supply chain to come together to work. So we're not looking at just solving one minute problem. We're looking at it in such a way that it affects the entire supply chain. So just to give you an example of what each of the grants look like in terms of funding, for research starters, we have project size that range between £28,000 to £56,000, and they could run up to a year. And they are led majorly by businesses, but farmers itself. Unlike the other ones, which is the feasibility studies, which is between 200K and 500,000 pounds, and can be up to 2 years. And this is just for for the industry to say, we have a problem, we don't know how it's going to work. How do we trial this out? It informs the go or no go type of situation. We have the small R&D, which is £1 million to £3 million, and could run for 3 years, and it's led by businesses. So you've done the feasibility studies, you've seen that this idea actually works in practice, and you want to take it one step further to develop, a sample or a product or service that farmers need. And then we have the slightly larger one, which is called large R&D, which is between 3 million and 5 million pounds and can run up to 4 years. And the last one, which is work on long-term innovations, is the themed competitions. So this could range between 2 million and 6 million pounds, depending on what type of competition we're running. And the reason for that is just because, if we're responding to different issues, like if you're running the competition on automation and robotics now, the kind of grants that they need is different from if you're running the competition on bioadditives or something else. So this could range depending on what the government or what the agenda is literally all about. Current FIP fundings, we have two current fundings are currently available right now under the Farming Innovation Program. That's the smaller round 3, which is closing on the 25th of October. And then the feasibility studies, which opens 2 days ago, 20th, so which opened 2 days ago and closes on the 15th of November. And you can check on the Farming Innovation Program website, which is farminginnovation.ukri.org, for further details. It gives you all the links that you need within that website. So under the Farming Innovation Program, we started in 2021, and I think as of now, we've committed about 130 million pounds out of the 270 million pounds available. And this is, just a brief rundown of what we funded, with research starters starting with 1 million pounds all the way to what we currently have available, which is marked in green. And there's still time if you want to apply, if you want to prepare, please jump on board, and I look forward to seeing any of your applications. Now, moving away from Farming Innovation Program, this is an Innovate UK funded program, which is not DIFRA related, but we've recently closed 2 opportunities worth about 39 million pounds, which is Better Food for All, and then the Novel Low Emission Food Production Systems. And those are their objectives, what they're trying to achieve. So it ranges from food quality to preservation, from plant-based produce to total control environmental systems and everything. So what we try to do is to look at it across the length and breadth of the system on how to help research, or how to help research and innovators bring their products very, very fast to market. These are some of the projects that we funded, example of the projects that we funded under these 2 competitions for you to see. So you could see novel proteins, and then you could see cellular agriculture and all the other things. Currently, we have a bilateral competition that is open, which is a bilateral competition between the UK and Canada. We fund the UK side of it, Canada funds the other side of it on plant-based proteins. So if anybody is interested, this is an opportunity that I would say do not miss, especially if you're targeting a global market. We also have other fundings that are available on the UKRI website. You will see fundings on refillable packaging for food and beverages. You see alternative proteins. The food and beverage one is open 2 days ago, but the one on alternative proteins and knowledge center is not yet announced. Well, it's open, it's online, but it's not yet. The date is to be confirmed yet. So if that's one of those things you want to key into, I'll recommend that you look through those websites, and you can see the questions that are going to be asked, the thinking and the agenda that we're trying to drive here. So for the Farming Innovation Program and other competitions, we have a lot of support to new applicants or even existing applicants. One of them is, well, 2 of them is the Innovate UK KTN, and the other one is the Innovate UK Edge. To describe this, the easiest way I try to describe this is KTN supports applicants pre-application, while Edge supports applicants post-application, or post after the grant funding has ended. And one of the things KTN does, which they really don't like me talking about, and if you ever mention it, I'll flatly deny I said this, is that KTN helps businesses, when you're applying, to review applications. So if you're writing an application, a grant application, and you send it to KTN, they can help you review it, offer suggestions on how to improve your application, free of charge to you, no cost at all. We cover the cost. Now, the interesting thing about it is that it's improved the standard of applications that we receive, but then it's made our competitions more competitive, So, but it's free service to anyone that wants to key into it. And I would always recommend that any applicant keys into it. While the Innovate Edge takes it up after a successful project has been completed, how do you scale up? And that's where Edge comes in. So we provide all the support for applicants anywhere within the UK to key into. There are so many other funding opportunities that we have on our website. One of them is the Smart Grants, which is on a rolling basis, and if anybody that wants to apply to those, they don't have any specific scope. So you can apply with any business idea to the smart grants, but they're also also available to all the applicants. And then if you check on the UK Research Council funding, you can find other applications. And that is going to be the last of my slide. I tried to rush through it because I know that Vishuu is still going to come and present some things about one of the projects that we have with University of Essex. Thank you very much. Do we take questions or later?
We can take questions now if you want. Any questions for Paul?
Okay, please.
I've got a question sort of around terminology and that. Just when you were talking through the Farming Innovation Programme, you mentioned resilience a couple of times, that actually one of the aims of the programme is to kind of improve resilience. And then you mentioned as well like a government aim to promote kind of environmental resilience. And I just wondered from the point of view of both the government aim and then the UKRI aim, what do we mean by resilience here? What's meant by, what kind of resilience do we mean? Like what's the aim of that? Is it about economic resilience or returning to a status quo post-shock, or is it adaptive capacity? I'm really happy to take that.
Yeah, thank you very much. So basically, we're looking at it from the environmental resilience. Right. How do farmers, crops, how do crops or livestock or, how do they withstand changing climates? Okay. Yeah, and one of the things we funded in the past, the competition we had was actually specifically on that, on environmental resilience. And so, what are the new ways? What do we do? How do we grow crops in such a way that farmers can make profits with the changing climate? We both saw what happened this year, where we had about a couple of weeks of summer in the entire year, and against last year, where we had extreme heat and there was water pipe ban and everything. So these micro changes in temperature, in environmental conditions, affects plants, animals, even humans. In wide various ways. So, responding to that resilience, making sure that farmers are, they have all the tools in their kit to be able to safeguard their crops, make a profit from it, and so on. That's what we're referring to here.
Thank you. Yeah. So it's kind of not how do things stay the same in the new world, it's how do we change things because they're in the new world.
Yes, how do we change things because there's a new world?
Okay.
Yeah.
Great, thank you. That's really helpful. Cheers.
Okay.
Paul, I just have a very quick question.
Yes.
For the research starter calls, if it is a startup, a very new startup, do they have to invest, put a part of money as?
Yes. So that was one point I failed to mention. All our calls, we expect that businesses have a bit of skin in the game. So our grants are usually for small companies up to 70%. For medium companies, I think it's about 60%, and for large companies, it's about 50%. So we expect for research starters, startups cannot apply to research starters per se. It's farmers that is geared to us, farmers only.
Only farmers.
Yes.
Okay.
So the way the research starter work is that we partner with KTN, and once farmers apply, they give a rough example of what problem they're having, and then the KTN would help them find collaborative partners within the research sector to help them take that idea, write an application. So KTN actually provides a lot of support in helping farmers write an application, because we all know that farmers are very, very busy. So KTN provides that support in helping them write an application with research starters and collaborators in order to, apply to that event. And I think that's one of the most successful competitions I've seen in recent times, because they have a near 100% success rate. Because we're talking about real-time issues that farmers are having that are very germane to them, that they can, is their experience on a daily basis. And so after they go through the research starter, if it's very successful and they want to scale up, then we can go through all the other process of feasibility, small R&D and large R&D.
So the farmer has to contact KTN first, or can
the farmer can just fill in a form and then they get contacted.
They get contacted by the KTN.
Yeah.
And then the KTN will recommend academic or
They
collaborator?
they will recommend academic partners, and if farmers decide that they've got their own partners they want to work with, the KTN provides support for them. So, we don't control it, we recommend, but then we work with.
And it can be a small farmer with local.
Any farmer.
And how much does novelty impact in the application?
How much what?
Novelty of the project. Or is it just I have a problem I want to solve in my farm?
A lot of them are very, very novel. A lot of them are very, very novel. Some of them, if they've been contacted because there are already existing solutions, they help build on the existing solutions. So, it depends on the reason and the challenge that the farmer is having.
Okay.
Yeah.
Good. Thanks. Just so you mentioned the success of the research starter. What is the success of the farming innovation? How competitive is it?
I know that's a trick question, Vishuu. Well, Farming Innovation Program has been very, very competitive on its own. Both the feasibility studies, the small R&D and the large R&D. They've been very, very competitive. However, I would always appeal to people to try and apply to them, because one of the things we do is that we allow resubmissions in the Farming Innovation Program. So if you apply to the Farming Innovation Program, if you are not successful, you get 5 industry experts assessing all the applications, and they give quality feedback to the applications. And initially when we started, we were not allowing resubmissions. But then we looked inward and critiqued ourselves to say, what's the point of giving feedback if we are not allowing it to be reworked and brought back into the system? So our assessors, which goes from a farmer, a sector expert, an academician, a technology expert, and who's the 5th person? I think an innovator, looks at an application, they critique it, they give valuable suggestions, which we always encourage people to work into their next application and resubmit. So currently we have a resubmission, and I'm trying to avoid your question, but just to pass across information that I think it's very, very relevant to the people that are here.
Okay, thanks, Paul. Are there any questions for Paul, or we can take questions at the end, maybe? Yeah, good. So thank you, Paul, and let me quickly come to my slides. And do the reviewers change if I resubmit they change?
Yeah.
So then now we get a new set of.
All the time, because we don't control who the reviewers are.
Okay.
Yeah.
Okay, got it. Let me just quickly try to. Where is the? I'm kind of used to it. Okay, good. So in the next 10-15 minutes, I will just quickly go more into the research side. So I'll summarize some of the work which we are doing. So in my lab, we are currently involved in 4 large projects, and there is a 5th one. And each of them have their own different flavor. So one of it is funded by the Transforming Food Production. This one is the Farming Innovation Pathways, a very, very competitive call. And the remaining are from the European Union. And all of these projects have shared challenges, which we kind of heard in the first talk this morning. So when I was listening to the talk from Rob this morning, again, he already mentioned many of the things in this slide. So there are a range of, but why robotics? Because many of these tasks are highly repetitive, highly laborious and low skilled jobs, and in very harsh environments for which there is no labor available. So that's one of the things. The second stream is feeding the world, food security. And the third is climate. So all 3 were discussed this morning by Rob, so I won't go. But all of these things are interlinked and drive each other. So that's why consumer-centric, connected and planet-friendly robotics can be a very strong enabler in this direction. And that's some of the things which I do in my work at the university. So I'll very quickly describe 3 projects. One is the strawberry work we are doing on strawberry harvesting. The second is, which one was it? Mushroom picking. Mushroom picking is the latest one. And the third is salad harvesting, which Roberto is leading. So this project, I mean, what is new is that we are not looking for crop-specific solutions. We are looking for configurable architectures. So we are testing the same system on both tomatoes and bell pepper, in addition to strawberry. And this is in collaboration with Tiptree, the world famous jam maker, in the country's first vertical growing system for soft fruit. So they have doubled the production in the same area. And most of the research problems kind of cover the whole spectrum of robotics, from perception to action, learning, decision making. So I'll just summarize what we have done so far and some of the new things which we were doing. So I started this sometime around 2020, exactly during COVID. So the strawberry season of 2020 March was exactly when we started. So I lost the first season, completely washed out. So how usually when we do perception, I mean, we have to collect data in the farm, and we couldn't go to the farm. So we started looking at fake data. So when you don't have it, you can fake it. So what we did is, I mean, just take a background, take a fruit, create fake occlusions, and then you can generate a range of synthetic images. So this is a completely fake image of a strawberry. There is nothing like this in the real world. And then you can train a system to learn this, and then we tested it in the farm. So and this is kind of the results we got. I mean, so basically you can create fake images and then train a neural network and develop vision system. So it kind of speeds up learning, because data collection and manual labeling is highly time consuming in the farm, and it opens up many other interesting possibilities. So you can also, in the real agricultural environment, there are lighting changes, there are lots of other things. So you can also impose artificial lighting in the fake data set. You can also combine, you can create synthetic images of rotten strawberry. So this is a strawberry combined with a blueberry and a mushroom to give it an appearance of a rotten strawberry. And you can generate thousands of computer generated images and then train neural networks, which can then be used to identify these, because these berries take energy from the plant. So while we are picking the good berries, you can also remove the rotten ones and detect weeds. So this is one of the things which we are doing. And in addition to that, I mean, the canopy structure is very variable. So we are also categorizing every berry into easy, medium, and hard. And in this period, we want to achieve 100% accuracy for the easy berries. The hard berries, we know where they are. So that's, the human is going to pick it. So it's being allocated to the human, because anyway, someone has to service the punnets. So there is all these things. So we are kind of classifying every single berry. We know where it is, what is the complexity. We know what, where. We've also started counting the number of ripe, unripe flowers for the predictive yield estimation, and allocate it to robot hands or human hands. So it's all done at the same time. Action system, I mean, again, we are doing something novel in this side. So it initially started during my PhD, where I worked on controlling this humanoid robot in Genoa. And then it's been applied in electronics assembly. But it's inspired from studies on the neural control of movement in the brain, so impedance control, mirror neurons, and it's a very configurable framework which can be applied to many different robots. And many of the manual tasks come with a lot of constraints, and they keep changing as the environment changes. So it's kind of based on neural control of movement. And again, for the robot navigation, we are building models which are inspired from studies on foraging in rats. So what the robot builds is a cognitive map of the farm, and then uses it for goal-directed navigation. We are also using the same architecture for navigation in hospitals, because hospital is a completely unstructured environment, people moving around, so human-aware motion planner. And the same thing is also applied for the vertical farm. So what the robot does is kind of builds an internal map and then uses it for goal-directed navigation. And yeah, I mean, again, there are vertical farms again introduce their own problems. So the first thing is that because there are multiple layers, the top layer introduces a big shadow, and usually we don't see anything. That's why one of my colleagues is holding a light when we initially started. There are berries everywhere, so you need to have some kind of attention system which can remove the distractors, because in a vertical farm you just see berries everywhere, below, behind. The second was when I initially started, I mean, this is the amount of wiring we had, and it's impossible to use this kind of a framework in the farm. So we did a lot of re-engineering. We are building a lot of stuff in-house, but we are also assembling some of the commercial arms, 3D printing, and we use a range of technologies. So now the robot is completely wire-free, and the battery is what goes inside. And then comes drift. So these are uneven terrain. So even if you want to go in a straight line, the robot does not go in a straight line. So it goes like this. So drift correction. Berries are soft, deformable, so no contact with the berry. So we are designing in-house 3D printable actuators, which are very low cost. So that's again another thing which we are doing here. And all of these, I mean, took. In addition, while working with a grower, I always give this example of, so they always need an easy to learn user interface. So this is like a washing machine. So press one button, it does that job. Number two, it does another thing. So at the moment, there are 9 different functionalities which are easy to use with visualization. So they can see what's happening, the visualization of the vision system, arm, logs of every operation, and safety embedded from low level on the actuators to the high level, which is the cognitive side of things. So this is something which now we've started training people at Tiptree. So now the robot is continuously in the farm, and the staff at Tiptree are kind of using the system autonomously. And by this season, we want to get 100% accuracy for the easy berries, and medium also we are picking. This is just a very quick video. So more recently, we have started counting the ripe, unripe, and flowers for yield prediction, eye-hand coordination. And we also have our own 3D printable actuators, which kind of, and there are no cameras in the end effector, so it's this is very interesting because more recently, this is like slowed down 4 times or 5 times. So now there is also the error correction combining the body and the arm movement. So if the robot, and this happens like in few seconds. So now the berry is shaking, but the system is operating real time, and you'll see the body driving backwards, little bit, very little adjustment to the body, and then it re-attempts. So there is a inbuilt error correction system, which if I miss, it adapts to failures. We are now optimizing for the speed. So my initial focus was on accuracy. Now we are focusing on speed. So it's around 3 to 5 seconds cycle time is what we are having at the moment, which is reasonably good and in kind of state of the art. So that's kind of the strawberry, but I'll just come to 2 other examples which we are doing. And the second is mushrooms, and this is funded by the European Union. So strawberry was more on the eye-hand coordination. Mushroom is a completely different challenge. This is how the mushroom bed looks like. So they grow in all kinds of orientations, which is very difficult. But in strawberry, at least I can cut the stem. In mushrooms, the challenge is that the root system is highly variable based on the harvesting conditions, and you can only know the root when you touch it, so the resistance of the root, and just uprooting it never works. So only the top comes out. So the root system is something which makes it even more challenging because it's very dynamic. And the third thing is, in order to uproot, I have to make contact, and these are very, very delicate. So very sensitive to application of force because they get blemished. And so these are the 3 different challenges. So in this case, I have to physically make contact with the mushroom, and then it's a very haptic and a dynamic task. So we were thinking like, how do you automate this kind of a thing with a robot? Because at the moment it's completely done manually. It's a very difficult task. And again, there is a lot of work on reaching and grasping. Even I do work on goal-directed reaching, grasping. But once an object is in your hand, what happens? It's a very gray area. What do you do with an object once it is in your hand? Because it combines the sense of touch, force. So that's the gray area which we wanted to explore, and humans are very, very good at this kind of task. So we wanted to build a robot which could kind of solve this platform. So again, it's in collaboration with the industry. So we are basically building the system which directly works on the standard 1.34 meter shelves in which the mushrooms are grown. And humans, use a kind of a three-fingered variable grasp based on which mushroom they decide to pick, and every shelf is different because they all grow randomly. So they use a wide range of strategies. So our initial guess was, to first pick the mushrooms which are topmost. So from the point cloud which I get, interact with mushrooms which are the tallest and the largest. So then it creates space for the rest of the mushrooms, and then you can pick more. So you have to basically organize the space. So you have to plan which one you pick. And we also thought we can learn from human demonstration. So that's the nice thing which we are doing in this project, and then build a soft gripper which can harvest the mushrooms. So in this, what you see is the human is using a force glove, and so there are 6 sensors, 2 in the thumb, 2 in the index finger, and 2 in the ring. And we are collecting data on where do they make contact, what is the force applied. And then we are kind of training a reinforcement learning agent. This is again synthetic. So I can generate thousands of configurations of mushrooms inside a computer, and then train a reinforcement learning agent which kind of gives rewards based on the performance. So you can see that there are many, many configurations, and then a mushroom is modeled as a spring, elastic, viscoelastic system on which the force also changes. And now we have started doing field trials. So the humans also do this little twisting task. So now we are doing field trials with this robot in the real world. So that's the second, which is more of a haptic task with more of force, contact, and that kind of a task. The third, which is this is my last, which is funded by the Farming Innovation Program. So all of us are kind of aware of the traditional, manufacturing, car manufacturing line. So what if we reimagine cars to be replaced by crops, and if this was a farm instead? So that was kind of the initial thought of what we wanted to do with this project. Very innovative, and so in such a structured setting, because the previous 2 examples were completely unstructured. The canopy structure keeps changing, the mushrooms grow however they want, but can we bring structure into the way the crop is grown, and then in that semi-structured environment put robots for the repetitive tasks at high speed. So for this we worked with a farm which is one of the large producers of salad crops. So this is a pool, and there are many growing beds, so it looks like this. And then there is a little walking space, and then there is a water flume. So the water flume kind of acts as the conveyor belt to carry those floats. When it is a baby, it starts from here, and once it completes the full cycle, it's ready to go for harvesting. And in this kind of a structured setting, we wanted to deploy robots in 5 different tasks. Very, very difficult, some of them. Some of them are easy. So that's kind of the 5 tasks: transplanting, handling floats, and these are very laborious for humans. So root cutting here, packaging, and this is the last one which we are not dealing with, which is a kind of washing the floats to recycle them. So at the moment they have a water jet. So the peat gets stuck here, okay, and now the human has to scrub it, put something inside and to remove it so that the float can recycle and grow one more plant. It's again a very, very manual task, scrubbing of these floats. Even with the water jet, it doesn't work. So this is something which we thought it was out of scope because it's a project in itself. So mainly we are looking at the pick and place because that's the easiest we could start. So the three tasks which we were looking at is, one of it is the transplanting of seedlings. Again, it's a it's one of their bottlenecks because they can make 10,000 of these lettuce pots in 1 hour with a machine. So 3 centimeter by 3 centimeter, 1 seed, 4 drops of water. But then these have to be manually transplanted. And the root is a living tissue. So, it has to go inside so that it can absorb the nutrient solution. So it's not just a normal pick place, it's a pick place and insert taking into account the variable length of that root. The second is very laborious, and this was probably the most challenging one, which is a human is standing in the water and is lifting these large floats. So it's a payload of 6 kgs because it's 8 large lettuce, approximately 400 grams each, and then there is a water absorbed in the root and the float itself. So the human has to repetitively do this for hours, standing in water. And robotic grippers put them in water. How do you pick those things in water? Vacuum gripping does not work, magnetic gripping does not work. So how do we handle this kind of task? And the last task is, so here I am cutting the root with my left hand and grasping the lettuce with my right hand. This is a packaging station. So can we automate this task? Again, human beings are currently being deployed in doing this kind of thing. So these are the 3 tasks which we wanted to work on. So, in this case, we started with transplanting, and so what we are doing is we are learning from human pickers. So we are kind of analyzing the motion trajectory, reaching the joint constraints, wrist, elbow, what is the speed, what is the velocity profile. And it's the same neural network which we are using for strawberry picking, which is now transferred for a different task on a different robot. So this robot also comes with a sensitive skin. It's a commercially available robot, so it's safe to operate in its vicinity. Oh my God, did I put everything in that video? So yeah, at the moment then we thought that only one robot is not sufficient. So at the moment we have a dual 2 robot configuration. So one which is transplanting, the other servicing the floats. So 2 robots, and at the moment we have installed 2 robots in the farm at the transplant station, and one is going to come in the harvest station. So again, these 3 examples cover the whole perception, action, learning, decision making. Human-robot collaboration is another factor in how the workflow in the farm will change when humans are working alongside the robot. That's something we are exploring very seriously for both strawberry and lettuce at the moment. Yeah, what we are looking for in the near future, in the next months, is ABC, because we are almost at this ABC stage of smart farming. So adaptive, biomimetic, cost effective, because farmers are very, very worried about cost, and a 150,000 pound robot is not commercially viable. So we want to at least 10 times reduction in cost, 3 times reduction in speed, and power consumption, and all the other sustainable things are the next things which Rob mentioned in his talk. But at the moment, the farmers just want the labor problem solved. It's a critical issue for them. So the high value tasks, the manual repetitive tasks, is something which they want us to solve. So I also want to just conclude with just that, while we try to build robots that sense, act, learn and interact, we are kind of solving the same problem that the brain solves to make ourselves do the same thing. So there is a other way round of this research, which is basically understanding ourselves by building intelligent robots. So on one hand, I mean, some of these can be transferred to other applications. So we are also a part of the National Center for Nuclear Robotics. So some of the things which we do in agri-food can get transferred into other domains. And yeah, I mean, obviously it's a very interdisciplinary field, like Rob mentioned, biological sciences, psychology. So I'm very happy to speak to anyone from these areas. So that's kind of the summary of the work which we are doing with, mainly with projects funded by Innovate UK and the European Union at the moment. So yeah, I'm happy to answer any questions, any collaborations. Yeah, that's it. Thank you. Any questions for me? Go on. Yeah.
Can you just explain a little bit about this balance between speed and accuracy? Because
Yes.
you know, when human labour can probably work for a 7-hour shift, and then you have to change shifts.
Yeah.
And you've got day workers and you've got night workers.
Yeah.
Robotics are not impacted by any of that.
No.
So my intelligence says, well, just concentrate on the accuracy because you've
Yes.
got 24 hours non-stop working.
Yes.
But you refer to speed as if there is a compromise.
No, we want to achieve, you're right. I mean, my initial focus was on accuracy, because if the berry is not picked, if the damage is too high, some farmers want like tip tree, exactly 1 centimeter stem cutting. They want to categorize the good berries, which are like nice looking, and the other ones go for jam production. Initially our main focus was at least for 2 years, 2 seasons, 2 years was on accuracy. But then we also we are comparing with the human pickers, so we wanted to at least reach 45 berries a minute. Humans go up to 60, to the fastest is up to 70. So we wanted to also focus on speed. Was the second priority to us. But along with accuracy and speed also comes the cost. So how many people can one robot replace, and what is the cost of that robot? So if the robot is 150K and it replaces 3 human beings, it's not commercially viable, because they have to pay the salary anyway, and these people are not available. So it's a combination of 3 different constraints put together. So at the moment, I mean, speed is we focused after we got the accuracy, and now it's like approximately 45 berries. 45 berries reaches 10 kgs in 1 hour if every berry is 7 grams. So yeah, now Tiptree wants me to slow it down because their staff is not very happy seeing abrupt movements. So it's very fast. So I'm kind of slowing it down. So it's a kind of a thing which we are working together with the grower. But importantly, I mean, lettuce harvesting is very commercially viable. So it's like, even if 2 robots work for 14,000 hours, the company saves 250K because the robot is cheap. But the strawberry robot is expensive. So now I'm building a low cost 15K version, which then will, if that robot can replace 3 human beings, even if the speed is reduced but has the accuracy, it will be a game changer. So it's kind of balancing different requirements. And
if I can have a follow-on question.
Yeah, please.
Obviously, human workers as well will work on a fruit farm in the summer. They'll then go do something else in the winter, or they'll go work in a hospital or a care home. Have you thought about robots that you could multi-purpose? So
Yes.
you literally plug it in to do
Yes.
strawberries for
Yes.
8 weeks, and then it works in a hospital?
Yes. Yes, that's one of the main focus, configurable and modular architecture. So from the sensory level to the action level, that's where, we are using the same neural network which was used for strawberry, also for lettuce. So the same arms could go and do transplanting of lettuce, running the same system. So yeah, I mean, that's something which...
Because that would make the business case.
Yes, yeah, absolutely. And also with the vertical growing and all this indoor, the season is increasing. So now the tip tree, we will have the season till November. But this year it started a bit late, end of May. But I've been told that we can work at least till end of November, mid-November at least. So yeah, I mean, the seasons are increasing, and there are growers in other countries. So we have requests from China. They are growing strawberry 24 Yeah, full,
365 days a year.
yeah, yeah. So there are companies which are now started growing even because of the demand and the innovation in the growing. So yeah, that's something we are looking at. So good. Questions? Any other questions? Yeah.
It's fascinating. That really helped me understand the process involved in kind of starting off this robotic takeover of horticulture.
We are not there yet. It's a very difficult.
But I can see it in the future because I've got a niggle in my head about you can see a scenario where the labour shortages are dealt with because we've got this kind of flexible pool of AI-enabled robots that can work in agriculture and hospitals in different sectors, who can be deployed in different places, partnerships between public and private sector. I can see that in the future, but I wonder if, as part of the research that you're doing, you also look at what the limits of those, like, comes back to my resilience question before, like, in what rubbish climate change scenarios in which we are constantly buffeted by heat waves and droughts and severe storms, like when the robots can't work in those situations because there's disruptions to energy supply or it's too hot for the robot.
Yeah.
Do you take that into account?
We
limits to that, and then how do we ensure that the robots don't function and then our food supply dries up?
Yes, yes, we have not encountered that kind of a harsh situation yet, but we do take into account, for example, in the lettuce harvesting, which is indoor, it becomes too hot and too humid, and the cameras have to be cleaned every day because it becomes wet, and so even the robot, because of the humidity, the control system is overheating. So we are just scratching the surface of it. At some point there will be limitations, and we need to build more resilient. Energy is again a problem which we spent a lot of time because battery operated robots. So at the moment we have like 3 hours and then we recharge. So there are two battery, but again that's something we want to look at, solar or some other. So that's again, but we are just scratching the surface. The main problems which we had on robots not being able, and water again, in the lettuce harvesting it's too much water, so we have to re-engineer, take out all the electronics outside and then build a 20-meter cable which then goes through the wall. So we are kind of taking into account all these safety because he faces those problems more. In the strawberry it looks fine. We didn't have big problems, but mainly for the hydroponics and those putting robots close to water and very humid, very hot environments. We haven't done any work in the summer months yet because the robot was just installed a few months back. But next year we'll see how it goes. Yeah. Good. There are no other questions, then we can. It's almost time, 1 o'clock for lunch. So, yeah, go on, please.
Can I ask a quick question?
Yes.
It seems very much that you're taking farms that were designed for humans to go in and do things, and then trying to retrospectively add robots into that situation. Even the fact that the strawberries are up here, right? That's presumably
Yes.
the convenient height for people to pick the strawberries.
It moves around also, so I can adjust the height based on what fits my robot. So now we know the exact height, which is a sweet spot where you get 100% accuracy. So it's like a...
Yeah, because that was my question. So do you really just want to redesign the whole thing to fit around the robot if you want to reach the...
Yes, I would really support that. In JEPCO we are making a lot of changes to the farm. So change the way the produce is grown and then embed robotics for the, because replicating the dexterity of the human hand is still very challenging. Robots don't have touch. If we can make life, even Tiptree, I was telling them just to tilt. So it's like this, no? If they could just tilt it, because anyway it's moving up and down. If they could just tilt it, it's just 2 cables all the strawberries will hang down. You know, these are small changes. And initially when Tiptree, I mean, things were grown on the floor, there were no pickers. Just by raising the height, they managed to attract more labor, and it kind of increased their production by 40%. So very small changes, like just take the strawberries grown at ground level to a more ergonomic. You can attract labor, and then humans are coming. It's easy for human beings. So small changes. Now we are kind of exploring also this kind of a tilt or something, which, because otherwise you have to change the way the strawberry is grown. But even small changes which are doable can really help robotics, because I mean, one thing, I mean, in the FIP public for the Scarlet, I mean, the first line which I wrote in the public description was that if you have to pick a strawberry in darkness, should I design a very high complex deep learning based AI system or switch on the light? Switching on the light is the easier thing. So again, I mean, if we can be more creative on the way the crop specific side of things, it really helps. The lettuce farm, we know the dimensions of every float. So the large float has 8 lettuce. So it makes computer vision very simple, because there is a structure. I know the dimensions of every float. I know the locations. So it makes things simpler. So even little things. But then there are so many floats that farmers are reluctant to modify them. So if I have to put a magnetic, we were looking at magnetic grippers, but then that will contaminate the nutrient solution. So modifying, so there are limits to what the growers can agree, because they have invested a lot on all this technology already. So it's just finding that right balance, and they are always open. I mean, at least the farmers I have worked with, small changes which help us makes life very easy. Go on, Paul.
Yeah, you've talked about labor, you've talked about costs of manufacturing robots.
Yeah.
How soon do you think we will get to that stage where we will be able to have, a robot that is performing almost all the tasks in a farm, either from planting, transplanting, to cutting runners, and trimming, and also all the way to harvesting, when you have a fully robotic powered farm? Because labor, when I speak to farmers, one of the challenges has always been labor, and Brexit and COVID has even made it a bit slightly worse. So how soon do you think we're going to get to that stage that we have an economical, viable robots running farms and the quality food we want at a price?
I mean, at the moment, I mean, at least from the work I am doing, I mean, easy berries 100% this season, but then again the cost is the thing. So we have to redesign, and the cost will affect maybe performance. We have tried the system independently, but when you put all the things together, we see a lot of, so it's still, I mean, I would be conservative. I mean, runners, again, it's a completely different challenge, but one of the things which we are doing is configurable, where task constraints can be taken into account. Even yesterday in the farm, we were discussing pollination with honeybee. So can the robot do more while it is picking? Can it do something more? So we can kind of add multifunctional system. So yeah, I mean, it's still, I mean, that's why we need support of the funding agencies to support this kind of research. But yeah, I mean, it's going in the right direction, and it's very optimistic. So at least from the last 2 seasons, and we've learned a lot. So now we know where the problems are, and this is impossible without working with the grower, because if I sit in my lab and build a system, it's not going to work. So I mean, we face challenges every day on different things, and the farmers want the technology tomorrow. Okay, people have told me that if anyone does it, people will bite their hands off. Even sandwich is again a very big problem. I'm working on an Innovate project on sandwich assembly. It's an absolutely inhuman job, because you have to stand in a fridge. It's like a fridge where people pick chicken and bacon slices and put. It's an absolutely inhuman job, and there are like 3 layers of protection. And so I think I had a picture of that. It's just the next. That's me in the suit here. It's you cannot even breathe, and it's like a fridge, and it's a very, very inhuman task. So yeah, but I mean the challenge is really critical, and people want it tomorrow, but obviously it takes a lot of time to develop and take the research to a level that it first works, and then it is also commercially viable, and then there is the sustainability side of things. What do you do with the lithium-ion battery? What do you do with plastic, like Rob said? Yeah.